Okay, someone has just asked me how we approach question 11 in exercise 19B. Okay, so basically what we have got here is a scenario of a lift with mass 520 kilograms. Okay, is supported by a steel rod attached to its base. So they've got the rod there. It's not hung by a cable, it's held up by a rod. And the rod can withstand a maximum thrust of 15,000 newtons. So it can cope with 15,000 newtons. That's it. That's all it can cope with. The lift can accelerate at 2.5 meters per second squared and decelerate at 6.2 meters per second squared. What is the maximum allowed load in the lift? There's 4 scenarios that we need to consider, really. Okay, once we've thought about them, we might realise there was only one that was the most obvious. Okay, the first one is that the lift is going up with an acceleration of 2.5 meters per second squared. If you've been in a lift going up, you'll have that kind of funny feeling where you feel like you're being forced into the ground, okay? And so, yeah, we kind of have that scenario. So clearly, that's applying more pressure. There's more force that's being... we were pushed up, yeah. So the other option is that the lift is going up, but it's starting to decelerate, okay? Now, when you do that, suddenly, if you've been in a lift, when it slows down, suddenly you get that kind of light feeling in your stomach. You go, oh, I'm a little bit lighter now, okay? And so suddenly, at that point, you can see that essentially you could have 3,646 kilograms there, basically, newtons, whatever, but you could have 3,646. I think the answer was kilograms, wasn't it? I'm trying to remember. I can check the back. Give me a second. Yeah, so it's kilograms. So you could have had a weight that bit because you're going up, but there's not much force required because actually it's slowing down, so there's not as much force required to keep that movement going. The other 2 scenarios is that the lift is going down and accelerating when it goes down. Again, I mean, if we're just accelerating, going down quicker and quicker, you get that lighter feeling. And then the final bit is a lift going down and it starts to slow down though, so we have deceleration. Okay, and you'll know that if you've been in a lift and you're decelerating, you really feel it squashing down. And essentially we get 4 things. The first one, going up and accelerating 2.5. The maximum weight is 699.5. What I've done for this is I've done the resultant form. So I said going up, we have 15,000 minus 520 plus x, lots of gravity. Okay, because that's 15,000 going up. That's the mg going down. And then we have the ma, which is the resultant force that we've got going up. Okay, which is 520 plus x, accelerating up at 2.5. So each of these, you can see I start with pretty much exactly the same scenario. Other than here, because it's going down, I do mg minus r equals ma. Okay, so I have this bit here. Okay. So we basically have that, and then essentially I consider it. Now you can see this one here actually gives us the lowest amount. That means it's got to be the maximum weight, because if that's the maximum weight that the 15,000 can support, if we had any of these others as kilograms going in the lift, it would damage the lift and the lift would cease to function in this scenario. So this is our worst case scenario. That gives us our answer. The back of the book for this exercise is shocking in terms of rounding to significant figures. I apologise for that. Hope that helped. Bye.